Hello and welcome to the next set of examples we're going to be doing. We're going to be doing a few examples with angles of depression and solving problems involving that. As you can see from the directions, it says solve each problem, round measures of segments to the nearest whole number and angles to the nearest degree. So that's what we'll do. For number one, it says the angle of depression from the top of a sheer cliff to the point A on the ground, 35 degrees. If point A is 200 feet from the base of the cliff, how tall is the cliff? Okay, so if you remember, alternate interior angles have the same measure, and that's what we have in this case. This is 35 degrees. And so we're dealing with opposite over adjacent. We have the tangent involved. So we're going to say tangent of 35 degrees is equal to the opposite unknown height of the cliff over the adjacent, which is 280 feet from the cliff. Simple algebra, we'll multiply 280 to both sides. Tangent 280 tangent 35 is going to equal x, and putting that in our scientific calculator, we get 196 feet. Okay, number two, the angle of depression from a balloon on a 70-foot string to a person on the ground is 36 degrees. How high is the balloon? Well, let's first match up our angles. Angle of depression will match the angle of elevation due to alternate interior angles being congruent. And we are dealing with opposite over hypotenuse, so that is going to involve the sine. The sine of 36 degrees is equal to unknown x, height of the balloon, over 75. And simple algebra, 75 to both sides, gives us this, and we're going to plug that in our calculator, and it comes out to 44 feet. The height of the balloon is 44 feet off the ground. Okay, number three, a ski run's 100 yards long with a vertical drop of 280 yards. Find the angle of depression from the top of the ski run to the bottom. Okay, we're looking for an angle here. Again, alternate interior angles. We'll just call that x, an unknown. And we have the hypotenuse, 1,000. And the vertical drop, 208 yards. So that's opposite over hypotenuse. Once again, sine of unknown angle x. Let's make that look a little better. Sine of unknown angle x is equal to 208 over 1,000. Alright, in order to flip-flop the x and the 208 over 1,000, we're going to use sine inverse. Sine inverse of 208 over 1,000. Scientific calculator will spit out the value, rounded to the nearest whole angle, 12 degrees. Alright, and last one, from the top of a 120-foot high tower, an air traffic controller observes an airplane on a runway at an angle of depression of 19 degrees. How far from the base of the tower is the airplane? 19 degrees here equates to 19 degrees here. And we're dealing with opposite over adjacent from this right triangle, so we're dealing with tangent. Set up our equation. Tangent of 19 is equal to 120, or opposite over the adjacent side of the triangle, which we don't know. Call that x. Simple algebra to solve for x. Multiply both sides by x, divide both sides by tangent 19. We have 120 divided by the tangent of 19 degrees. In our calculator, that yields 349 feet, rounded to the nearest whole number. And there we go.